North Anna public meeting. Glad you could all make it out on this rainy evening. I'd like to turn it over briefly to my boss, the branch chief, who administers from the Director of Reactor Projects in Atlanta, Region 2, Mr. Steve Rose, for some opening remarks. And then tonight's agenda is just simply an open conversation for questions, and hopefully we'll be able to provide the answers to any queries that you might have. So Steve, please, if you could make some opening remarks.
Yeah, so this is an open house meeting, which we consider, we have several poster sessions here that we go through, several pamphlets that you can pick up. But we make ourselves available to the NRC. We have the senior resident, Greg Kroon, the resident inspector, Gwen Eatman. And then we also brought one of our health physicists, Bob. Yeah. Kellner. Yeah. So, and then we also had a couple of our headquarters folks that are joining us here today also. But basically, we're available to answer any questions that you may have. Feel free to engage any one of us associated with any of the posters or any of the information that you have. We'll try to get the answer for you. If we don't have the answer, we'll try to get that for you and get back to you as far as what that entails. So that's all we have. We do have a PowerPoint that's displaying here that kind of goes through some of the plant-specific indicators that we've for the year, and you feel free to look at that and ask us any questions. That's pretty much all I have.
Well, thank you. And it seems like every year when I come here, we're always a year behind. The radioactive effluence reports for 2017 is still not visible online. Only 2016. So I don't know when we had this meeting why we don't have last year's report for radioactive effluence.
Yeah, that's usually issued by the end of April, so that's why I shifted the meeting out now
It's
until
still not
middle of
up.
May, but it's still not out.
Mm-mm.
It's still not posted on Adams. It's not publicly available yet. It just hasn't been processed. It's been submitted.
Yeah.
Now, this
But
is a
it has been
reoccurring
processed.
issue every year, because then after this meeting, and then when the report finally comes out, then I have a lot of questions.
Yeah, and so that's
So-
why I tried to set it up now in the
Yeah.
middle of May with the submittal, but
Not out
unfortunately,
again.
so we can, next year we'll work to shift it a little bit farther out.
Yeah, that'd be good,
You know,
because
so
that way I
that's-
have a time to go over the
Sure,
information,
right.
because, we've had ongoing leaks and, well, some of the wells have, reported excess tritium in the past, and so I don't know where we are at this year.
Yeah, and so that's part of it. I know that was one of the topics that you were very interested in, and that's
Right.
why we shifted this out, in
Okay.
hopes of capturing that.
Well,
But,
maybe next year
Yeah,
then.
next year we'll cast the net a little bit further out.
Right.
Okay.
Well, if you don't mind, I do have some questions.
Oh, yes.
I know this past year, Dominion placed the experimental cask on the pad, am I correct? With the high burnup?
Yeah.
Well, my question is, it states that the burnup greater than 45,000 MWDs in a modified TN32. What is greater than the 45,000 MWDs? Do we know?
So you got that.
That is it's a little bit above that. I believe it's 44,000 MWDs. I'll have to double check on that.
You mean below 45,000?
No, excuse me, above around 46, 47. I'll double check on that and get back to you. on that.
Okay, and I do see too that Dominion has filed for the renewal of the spent fuel facility, the pads, for
Yes.
another 40 years.
Yes.
And so my question is, this experimental cask that's been placed there is supposed to be examining how this high burnup fuel does.
Correct.
So is it going to sit there for 40 years before someone actually, y'all are taking readings, and what are y'all doing with that cask?
Well, I'm not doing anything. The licensee is, and it's in a program with the cooperation with the Department of Energy, and I believe that they are in cooperation to take a look at readings over the next several years. But I do not believe there are plans for it to be out there for that entire time.
Well, from what I understand, there is no facility to actually open up the cask that's available as of right now. So I guess it's going to be out there for.
It'll be out there until the DOE is able to accept it.
Okay, do we know that, is there a dose differential between, because it's placed out there with the other, 27 casks? Is there a difference in dose in relationship to standing near that one versus the other ones? Do we know?
There's a little bit of a difference, but nothing of a significant nature.
Do we know how much the dose is?
Yes, we do. And typically that's running, what, Bob, what are those off the cask?
It depends on age, number
Yeah.
one, of what's been loaded.
Yeah.
When I did the walk down on the pad earlier this spring, we were walking through all of the pad, and the dose rate there was maybe half a millirem higher
Yeah.
than they were around the other
Yeah.
casks, the highest cask.
Yeah. I think the whole area is what, maybe a milligram an hour, if I remember last.
If you get in between.
If you get in between,
you get in
it gets a
between
little
them.
higher,
But I mean,
but-
at the perimeter, at the boundary, I mean, it doesn't affect the dose rate at the site boundary at all.
Correct.
I mean, the dose rate at the perimeter of the Istvasi pad
Right.
is controlled at less than half a milliround.
Right.
Or actually less than 0.2 millirounds.
And then the other question, I know when they go out there and examine these casks every, I'm not sure how often, and to make sure they're doing all right. I know that under, I guess, the typical way of doing things, they'll lift up and they'll pick some cask and they'll lift it up and then, put something under it with a camera and take pictures to see how it's doing underneath that.
Right.
Are we gonna be doing that with the experimental cask as
I
well?
believe that's part of the program, to take a look at I mean, that cask will come under the general oversight and general maintenance and surveillance of the entire facility. So it's treated in that regard just like every other cask.
So, well, I know, but we have 27 casks out there,
Correct.
and they don't lift up each one, they
No,
only
they don't,
pick
but they do
one.
a
and-
sample, and eventually that probably will be sampled in addition to any requirements in the DOE
So there's-
contract to take a look at
So
it.
there's no special requirement to look at that one specifically, is what I'm.
You would have to look at you'd have to ask the licensee on that, because it's a DOE contract that doesn't come under our purview and regulatory control.
Okay. And then also I noticed here recently, and it seems like Dominion gets a lot of these exemptions or amendments or whatever you want to call them. It sounds like, here in my notes. They're supposed to be checking the cold leg this time around. And they got an exemption to be able to check it when they check the hot leg, I think in 2022. Is there a reason why they didn't want to have to check it right now?
Well, Steve,
So this is Mike Markley. I'm
All
the
right,
chief
Mark.
of licensing for headquarters. Part of the rationale behind it was that they would have had to pull the pour barrel and other things, so it would have been it would have been an encumbrance for them to do that for outage, those and other things.
Okay, but we're dealing with these metal overlays that have been placed on some of these areas and some of these parts. And it looks like if you go back looking, it was in 2013, they could only examine up to 88%. And so there wasn't like 100% being able to see all of the above. And so then you go back prior to that and it was 80%, so we covered a little bit more. But if we're gonna take it out to 2022,
So it will depend on exactly what it is they're inspecting. The normal requirement is 100%. There may be a hardship for it. In this case, that's what it was. In other cases, for certain inspections, there's impracticality. Some of those practicalities may be the technology being able to get to the location. So it will vary depending on what the actual request is and what the actual location is. So each one of those pipe inspection areas are probably different.
well, I mean, obviously, at some point, they had expected 100% to be examined.
That's what.
And
we
it
would
seems like the
always-
hardship's been placed almost every time with how much they have to actually review or how much they have, the percentage. And I'm just saying that we've got some metal welds there, and we know over time these things develop at least small cracks or whatnot. I mean, are we really able to technically say that for sure that that's a good idea to go out to 2022 without these
What they
examinations?
provided was a sound basis for confidence that what they were able to inspect provided a reasonable basis and reasonable assurance that it would be unlikely for there to be a problem with those portions that they did not inspect.
So it's
It's based on the
Based on
sample
what?
they've already done. Based on the sample they've taken, they can make the case, a safety case, that they don't need to do the rest of the inspection this outage, because the majority of it, the 88% or whatever it is that they have inspected,
But then
came out
last year,
good.
but then the year
It's not-
before, it was 80%. I'm just saying, it seems like over the years, we're going by,
You're not
we're
talking about
not
the same well.
covering the large,
Yes.
100%.
Excuse me, but each one of those is a different well inspection.
Well,
We're
I
not
know we've
talking
got
about the same
multiple
one
wells.
80% each time. It will vary which well it will be.
Well, here it says
Inspection.
loop and welds, and it's got the different ones, A1, A2, B1, B2, C1, C, and they're all 88%.
Right. And we listed those individually. Those are the ones for which they got the relief. And they made it a sound safety basis for that, and we approved it.
Okay, but not really based on, I mean, I don't know how are you basing on it if you can't get the information?
I think I've explained to you that they did inspections for a majority of the wells, and they've made it a sound safety case for, it's probably highly unlikely that you'll have a problem with the remainder that they couldn't inspect for the remainder of that time period until the next opportunity to inspect. And the other basis for it was hardship for the outage. Old Corvale do other inspections, so.
Okay. Well, it seems like also in the past several months, there's been other plants around the country that have been having problems with the MOVs. And I'm wondering, where we stand here at North Anna too, because I also pulled up some saying that there have been some of these motorized operated valves that are in question right now, because some of them have been getting stuck open or stuck closed. Where are we with the different ones? Because, some of them actually deal with the hot legs and whatnot.
They're required to periodically actuate, operate the motor-operated valves to assure that they meet acceptance criteria.
All right.
So you're correct, some of the MOVs during time may show degrading condition and challenge the acceptance criteria. The whole point of the surveillance is to identify those MOVs that are beginning to have some problems, and they go in and they make repairs and effective remediation to them to bring them back into conformance with what their performance requirements are needed to be. Are you going to see in the operation of a plant certain conditions or certain valves that on occasion are going to start degrading? Yes. You can't, everything degrades eventually. You can't have a car that the starter never needs to be replaced. However, what they do is that they're part of their aggressive surveillance program, which we monitor, and part of our sampling is to look at what they do. They identify when there's degradation, and they effect repairs quickly and commensurate with safety significance.
Okay, because it seems like that the NEI basically said that they were kind of asking for Dominion to communicate this information, including repair schedule commitments as applicable, in a separate letter to in accordance of the NEI plan. So I just wondered, do we have some plans or scheduled plans for some of these
The licensee
replacements?
has provided, at least talked to me in my almost daily conversations, but on a weekly basis. They've discussed the MOV degradation and overall plan to take a look and make effective repairs over what we would assess as a reasonable time frame.
So do we have some that need to be replaced is what I'm asking.
I do not believe at this time there are any MOVs that are needing replacement. Because partly during the outage, for example, they did replace a number of MOVs.
I was gonna say, because North Anna 2 just came out of an outage.
Unit 1, that's.
Or was it I'm sorry, Unit 2 is supposed to get refueled and outage in next year.
Right, yeah.
Okay, so yeah, so next year's outage, is that what obviously they try to plan some of this work during the outage, right?
And they're already putting together the schedule for their outage in the fall for Unit 2, and part of that is MOV replacement.
Okay. Is there any other parts or anything that need to be replaced at this time?
At any refuel outage, there's a number of parts, a whole host of parts that go in and they replace them. A lot of it is predictive maintenance or parts that are prescribed to be replaced, not necessarily because they're showing the grading performance, but simply because ASME code recommendations of various sorts, or just simply their licensing basis requires them to replace parts periodically on a certain time frame based on what their license was originally agreed to, that we signed off on when we originally gave them their license, and now Unit 1 giving them their extension.
And so there's no major repairs or major part replacements that are going to be needed in the near term?
Not that I'm aware of, no. Just the simple, the common replacement and repair that you see in any outage at any plant.
And then talking about those valves too, I guess it's more than just those type of valves, because I think I pulled something else about some sort of gate valves.
Mhm.
And what kind of valves are those?
Those are, they're just a design that instead of, you have essentially ball valves, gate valves, it depends on the internals of how it regulates the flow. Gate valve is what you picture, it's just it's like a flat plate that comes down in the way of the flow that will seal off the flow. So those are used in various aspects in the plant, and just like with the MOVs, those valves go into a schedule for remediation, repair, surveillance, and replacement as necessary.
Okay.
Right. Sometimes with those, when there's industry issues that arise, may pop up at another plant that they've seen a problem, then that gets distributed through all the plants, so that all the plants can take a look at that. That's, operating experience that they share. And part of that, if it's a significant issue for us, then we'll put out some generic information notice to have the licensees individually take a look at that and report back to us as far as what their susceptibility is.
And as Gwen and I do our inspections, one of the important inspections that we perform is when that experience gets out or we release information like that, we make sure that the licensees capture that in our corrective action program and that they're addressing it or taking a look at it, so that we follow up on making sure that they've captured what we've sent out and they're addressing it.
Right. But the concept is that they get to it and identify it before it fails, where maybe it has failed in another plant and a different application and that kind of stuff. And so we look at what we call an extended condition, how does that exist throughout the industry? And then they look at that, let the licensees look at what their susceptibility is, and then we go back and
Well,
do the appropriate inspections if needed.
How do y'all check these valves though? Just kind of see if they open or close? I mean, how do y'all check them?
Well, there's different testing, like if it's a motor operated valve like you brought back before, they have a series of testing that it has to go through, and whether it has to stroke within a certain amount of time, or how much of the motor torque it requires to open or close the valve and those kind of things.
So
So they take measurements of all that.
So you do that while you're like powering down or powering up?
They
or
take the
with
system
all?
out of service and they measure those things during that time frame and then put the system back in service.
So
And so a lot of it gets done during outages.
That's what I was going to ask, if it's done during refueling or something.
Sometimes it's done during outages, or
Some are
sometimes
done
they'll
at full
do at full power because they have redundant systems, and so they can take one train, what we call it, out of service, and then be able to perform the maintenance on that, and then put it back in service.
Because I know Farley and another plant recently had to do a scram because they're having problems with some of these valves. So, I mean, obviously, there's safety connected to the cooling system, so.
And in some applications there are, and so those valves aren't necessarily always used in, those safety applications. Sometimes they're used in non-safety applications.
Well, I'm assuming we got lots of them.
Well, there's lots of valves in the plant, but not every valve that's in the plant or every motor operated valve or gate valve is safety related.
Well, I think this is what some of this NEI paper was basically about,
Right.
is because this experience, and I've been watching it as the reports come out, this
Yeah.
is happening all over the country with some of these valves. So that's why I think NEI came out with the paper, and then even asking Dominion to, I guess, correspond back with their findings or
Right. Yep.
something. So there's definitely some issue with some of these valves.
Right,
That's
so
why.
NEI is also collecting that kind of information from an industry perspective.
And, well, I'm assuming, I know that North Anna 3, the NRC gave you guys the license, I guess, to be able to build North Anna 3. How are we doing on that?
You'd have to talk to the licensee on that. That's a financial issue that if they decide to build a plant, it's based on finances. and other desires of the company.
So-
Yes, we gave them a permit, preliminary permit to move forward, should they desire Unit 3.
Okay,
And
so,
I-
well, financially, not really a, very
That's
expensive
not
venture, which, well, hopefully Dominion will go the route of more renewables or something instead of a third nuke would probably be better. And as it goes for, the thing I really did find a little disturbing is when I started finding out about, you know, how we do have, what's VHPs? North Anna 2, 14 VHPs with P. What's a VHP?
With vacuum priming.
What is that? This has something to,
VHP
this,
or
VHP. This had to do with, calculating the axial flaws, so it has to do with the cracking, and so much is allowed of cracking, I guess, before addressing it or something. So I was just wondering what exactly.
Well, let me just speak generically. First off, I'm not familiar with that system, so maybe if you could provide more information, I could follow up for you on that. ASME, American Society of Mechanical Engineers, have very
Right.
strict codes and standards as to what is permitted and what's allowed. And that's addressing part of the issue that you can, all metals are going to have some development of stress cracks or thermal cracks of that nature over time. The question is how do you mitigate it, and how do you make surveillances and visual inspections in non-destructive methods, and in some cases, pulling the parts out and doing destructive methods to take a look to see how the growth of those cracks are. So there is established programs, again, as part of the license basis, to go out and periodically inspect piping and things of that nature to assure, say, on welds and thermal joints, that the cracking is not significant, or if it's beginning to become significant, to be able to capture it long before it poses a safety significant threat to the plant, to be able to remediate and repair it. So,
And when it comes to the containment itself, I mean, I think when we were here last year, we talked a little bit about we thought forge and some of the cracking that was
Correct.
discovered.
Well, but-
I mean, are we able to check for the cracks that are actually in the containment?
they are able to go in and check for those kind of things, and it's part, again, of what they're required, it's a part of their license basis when they go into an outage. There are a lot of tests and a lot of surveillances that they have to perform prior to coming back after being refueled, coming back to power, that indicates that the plant is still in a safe, operable mode that will not threaten the public health, safety, and environment. So part of, again, Gwen and my job is to assure and look over those inspection programs to assure that they're meeting their requirements and that they're not finding, if they're finding things, they fix it, and if they're finding things that don't need to be fixed, it still is being identified for future follow-on activities. During the last outage, they did not identify any significant cracks or threat or anything of a safety significant nature or of a safety nature that could threaten the potential of the public health and safety.
I mean, it's pretty radioactive in there. Actually, how do they get to see the? I mean, how can they?
Well, some of it's, when you're talking about Christoph 4, you're not talking about the containment, you're talking about the reactor
The reactor
vessel.
head.
So, and
Okay.
it's actually what's the reactor vessel head.
All right.
And, but what they do is it is, active underneath there. And so what they'll do is they'll go through and do some visual inspections, and some of that's done with cameras, and some of it's done with actual.
So cameras can actually go in there and.
Well, that head, during the refueling, they'll remove that head.
Right.
And so that actually gets removed and put on a stand, and then now they can go and take a look underneath it.
So they're looking at just the head.
Yeah.
But what about the body is what I'm talking about. How can they, because don't they have some sort of pieces of similar metal little samples around in different spots?
Yeah, different
And
spots.
over the years, they
Yep.
pull those out and they examine those.
Correct.
But we've been operating for over 40 years. How many more of those samples do we have left?
I remember there are,
Take them out, put them in.
yeah,
They
there's,
replace them when they take them out.
We'll replace them with what? It's not gonna be the
No,
same.
They put a new
metal.
sample in, and now you've got a new baseline. So you've taken how much neutron activation there was of the sample that was there for however long, and they have different ones that they pull periodically. but they put new ones in to replace the old ones.
But it's not
as
gonna
it
be the
went through.
same metal though.
It's gonna be the same metal, that's what you're doing, you're putting it in there so that it will be irradiated in the same neutron field for X period of time, and then you basically look at the degradation and the changes in the metal over time. So it doesn't matter, I mean, you're operating the same power or whatever for X period of time, so you're still showing it the same amount of neutrons. So.
Well, yes, and,
And then you're gonna do the analysis on it. So
Well,
that's
what
really
I-
what you're doing, you're just
well,
taking a sample.
but when they started the program, the reason why they put so many samples in them, because they figured over time, that how much time they'd need. And then all of a sudden, we started running out of these guys. So now we're putting in new samples, but this metal is not the same reactor vessel metal.
As they've been going through, they've been taking out pieces of metal, putting in a new one, so that as it ages, they can see how much neutron enrollment, how much neutron flux it's been exposed to over the entire period of time. They just keep replacing them as they.
I guess
out.
I guess I'm not clear on what I'm trying to convey.
I think what you're saying is that the original samples you're presuming is made out of exactly the same forging as the original reactor vessel.
Well, probably closer to the whatever we're putting in there now that's.
No, that's not true. There's a certain, we know how to make particular alloys to a particular very close specification. So what's being replaced is yes, a new sample, but it is very close to the same alloy that the original reactor vessel was made out of.
But the point is that there are samples that are available to be tested to monitor the neutron exposure of the vessel throughout its entire life. And they have other inspections that are required on a 10-year periodicity and other schedules. So they're meeting all of those schedules for inspections.
Well,
For
I-
piping as well as a vessel.
Right, I just keep seeing these hardships where, these intervals are being put forward by, 4, 8, 10 years where they don't have to be looked at. So I'm just curious, and I do know that inside the reactor vessel, and the reason why they put them in the different spots was because you could have hot spots in different areas. So one area is not gonna be showing you really the whole vessel in itself. It could be showing you that spot, but it's not gonna be exactly the same going around it from what I've read. So, but like I said, putting in new pieces when originally the old pieces would probably give you and capture probably a little bit more of a realistic view of, because it's been in there that long, than putting in something new. Maybe I'm not making sense, but.
I think the bottom line is there are test methods that have been set up over hundreds of years for the now for 50 years in terms of radiation embrittlement that have been put together by experts and by engineers and physicists with high confidence that they can take a look at those samples and have a realistic and high assurance understanding of what the condition of the reactor vessel is. And it's a difficult concept, and it's a very detailed concept that many people spend years and years to learn. And, I think it's been put together. The NRC has its, I think, world-class experts in terms of metallurgy that have looked over the license and are assured that the surveillance periodicity and how they look at those samples over the time frame, it gives you a high-quality picture of the condition of the reactor vessel.
And now as Dominion's moving forward with the subsequential license to take these plants up to 80 years, are we supposed to have confidence that these reactor vessels themselves, when there's been engineers in the past that have stated that they were designed to last 40 years?
Yeah.
Yet now we're talking about taking these suckers up to 80 years. Now we can replace a lot of the other major components, but can we actually replace the reactor?
The burden will be on the licensee should they apply for such a license.
They already have.
No, they applied for 20-year extension. They have not applied for putting it out.
They're gonna be
additional
putting it
20.
in this year,
But
2019.
they haven't done it yet. So
Turkey
I can only-
Turkey Point has in Florida.
Okay, Turkey Point has. I can only speak to North Anna.
Right.
So the bottom line is if they choose to do so, it isn't just a 5-page paper saying we'd like to do this, is that okay? They have to provide extreme amount of detail and analysis, and the burden is on them to show that they can operate that plant out to the time frame that they're saying. And we're not talking just mechanical, we're also talking operationally, that they can support it operationally. And they support it financially. I believe there's financial requirements in an operating license. They have to prove that they have the financial ability to maintain that plant. So when it comes to, you know, headquarters for a long-term analysis and review, there will be a number of inspections. We've had a number of inspections that came out for the most recent plant extension, and to assure that what the licensee's providing is accurate, correct, and that providing us the confidence that their license extension request is accurate and worthy of merit.
And so a lot of it does predicate on exactly what you're talking about, the aging management, how are they dealing with the management of the aging of the plants and different components within those. So that is a big part of it. We're also working a lot of that aging management into our inspection procedures, so that when we look at it for exactly what you're saying, as the plants get older, we're gonna have to look at them a little bit differently, you know, in some of the inspection procedures.
But that's where I'm concerned, because these plants are already getting old, but Dominion gets these exemptions and puts off stuff for years. I don't mean like, okay, we're gonna put it off for 6 months. They put it off for years. I mean, now we're talking about like not reviewing like the cold legs where the welds are, you know, until 2022, because it's more convenient to do it at that time. But that's what I'm saying. I'm concerned because I keep seeing exemptions and amendments and changes that doesn't, in my opinion, preclude safety, but more convenience on Dominion's part. And that worries me. And I go back to this again. We were at the General Assembly this year, and Dominion's coming forward basically and wants $5.4 billion or something to, you know, put parts in or something at North End and Surrey to keep them running. Well, yes, we could replace generators, this, that, or the other, but when we come to one of the most significant parts that I'm talking about is the vessel itself. Now, everything I've read is that's not going to be economical or feasible to replace that. So we dump billions of dollars into these facilities that are aging and still end up with a problem with the vessel itself. And all we've done is waste a bunch of money. And that's why I'm concerned about the cracking, about us putting off these examinations, about 80% coverage, 88% coverage. And I don't mean just for a year. This goes back to 2012, 2000. I think when we replaced the head in 2002, 2003, we did the weld repairs on the cold legs in 2003. Yes,
So
I
4
keep.
years- So, excuse me, but 4 years is not much in terms of an extension of an inspection for a durable piece of passive equipment.
But
So-
they got some. But prior to that, they've got some exemptions. I'm just saying we repaired.
These aren't
the-
exemptions, these are relief requests. They're asking for relief to, and they're also not saying we're not going to do it. They're saying we would like to do it and do more inspections of other kinds when the barrel is pulled, and it's more convenient to do the range of inspections that could be done at that point in time. But to be honest with you, 88% coverage is pretty good. To assume that the other 12% is in good condition as well. That
Well, but
provides a
what-
very high degree of confidence.
Well, I'm just saying these are parts that are being, extra welds being put on them and stuff. And if anything, in my opinion, if we've already been making these changes and the plants are getting older, we should be inspecting them more frequently, not less frequently.
Well, but we are. When they come in for licensing extensions, there are sets of inspections, additional inspections that above and beyond the ROP baseline inspection that, again, Gwen and I do. We also have supplemental inspections that come in with RP, in-service tests, looking at the steam generators. We have numerous tests and inspections that come in during the year. And that's just for when the plant is operating properly. You throw in a plant, some of the more challenged plants, and there's additional inspections that come in. So your concerns are valid. We share them. We're not saying, oh yeah, we're just going to give them an extension. That's not. You have some good questions, okay? What I'm assuring you is that the public health and safety is our priority. We're not going to give an extension unless the licensee can clearly demonstrate that they can operate that plant into the future beyond the original license date with a high confidence of being able to, of a safety margin so that the public health and safety and environment is not threatened. And, for example, these extensions, they may be extending them, but I would probably bet that then they're gonna be necessary to have those completed prior to any additional licensing extension. Again, I think Mike brings up a good point. It's not permanently putting it off, it's extending it into time with the buy is if we give you a little more time, when that time comes, you're not only gonna do the original inspections and analyses that you want to, but you're gonna do additional above and beyond what you were originally required to do.
So the process really is an expansion of scope if they find defects, so, which is really what it is. So if they were to find during the next inspection that they had a growth rate that was more than what they expected, or a defect where they didn't expect it, that creates an expansion of scope. And that's what this actual relief was for the expansion of scope.
Well, I understand that, but my question is this though. If they're putting in the paper next year, 2019, okay, for a subsequential license,
Okay.
but we're not gonna review the cold leg until 2022.
So these will
I
all
mean,
get
so-
inspected during the current operating license, regardless of what period. These will continue to be evaluated through the life of the plan.
No,
That's-
I under,
They're not gonna get the extension in 2019, they're gonna submit it in 2019.
so
That's a
they're gonna
long
submit
process.
so they're
If
gonna
they do,
submit it,
if they do,
right?
right? So they have
So
another
that
20
gives
years
them,
they can
that gives them a
operate,
few more years to actually
perform.
perform all the
Right,
inspections.
it just begins the process of like, of the plant extension.
Aging
It
management
doesn't,
evaluation.
it doesn't happen like that. And one last point that I'd like to point out is the reactor oversight process. If you go on the NRC website, and I hope you do, you can see the inspection manuals.
I do.
And the inspection, and look at the inspection procedures, okay? Because part of those inspection procedures of the baseline plus the supplemental inspections that happen during the year give you a really good detailed idea of what we as the resident inspectors and other inspectors look at. The focus of what we look at has changed over time. And I think a lot is we are beginning to focus more and more on aging management. And then over time, you'll probably begin to see inputs into the overall inspection program that may start looking at those areas and be able to focus and shift focus into the areas that are of a concern as the plants tend to get older and begin to be, addressing the aging issue. So the ROP is a living inspection program that the NRC will adjust as time goes on and as needs require. So I think we are doing what you might say. In the future, I think it's very likely we will do more inspections in those areas that are becoming of a greater concern perhaps to you and to others.
Well, yeah, because when we ended up with the welds, because it was one of those, oh my gosh, look what it is, just like Davis Bessie.
Sure.
It was like, oh my gosh, look at this big hole. I mean,
Yeah.
it's kind of alarming, We don't want to end up with
No, we don't.
So that's why we
something.
look at it more along the lines from the extended condition. If something happens within the industry, then that may change the perspective on, granting relief requests or different things like that, or if the licensee goes in and they find an indication that, may play a bearing on the next relief request. But each one is considered on its own merit, and each one looks at, what they submitted and the amount of coverage that they were able to get, and what's left to do and what they've identified.
And I
it
have
also
more-
plays
I-
into what the industry looks
And
like.
I have
too.
more confidence, and this, that, and the other.
Absolutely.
So, of course, everybody kind of looks at that as, well, we can only hope that everybody's doing their job and doing what they need to be doing to keep us safe. But my biggest concern is, like I said, I was at the General Assembly last year. Dominion's asking for over $5 billion or whatever. So wouldn't it be more prudent, really, before these subsequential license come up, that the plants looked at and said, okay, we're gonna need to replace generators, we're gonna need to replace this, and then tell us how long do y'all think that reactor vessel? Because otherwise, what's gonna happen is every year Dominion is gonna come in and they're gonna want more money.
Well, I
Look, they
can
already
assure
got
you
like 600 and some
The condition
thousand.
of that
How
reactor
much was
vessel
it?
will be a high concern.
$600 million for the paperwork for North Anna 3. you know?
Understand.
And so, I mean, I'm concerned because these plants are old. And not only that, can't change the fact that it's sitting on top of a non-active fault line. And we've had, not exactly right there, but in the past 3 months, we've had 2 earthquakes, just 2.3s in Palmyra. It's not too far away. And in the past 365 days, we've had 19 earthquakes. We haven't stopped shaking. So, of course, I'm concerned.
And the bottom line is, I take my position extremely seriously. I've been entrusted by my branch chief, by the NRC, by the people of the United States, to be here at this plant to make sure that it's operated safely and it's not a threat to the public health and safety. I promise you, that is my number one concern. And if I were to ever see anything, I promise you, that I thought threatened the public health and safety, I would be energizing and I would be contacting my authority through my branch chief and the rest of the NRC to address the issue. I seriously go out into that plant every day with the sole intent to make sure that that plant is
And
safely
I totally
and
believe what you're
I
saying.
want you to understand that, okay? So you bring up a lot of important issues. They're very complex technical issues.
Sure, and
that are
I'm not an
difficult.
engineer, but I do a lot of reading.
And you do a great job at it, and I appreciate your feedback, because I think a lot of your comments are very valid. What I want you to understand is that, fortunately, for whatever reason, I was able to become an engineer, and I have some understanding of the technical aspects of it. Your questions are good, very valid. What I have is the ability, with my engineering background, to be able to go in and begin to assess the validity or the magnitude of the concern. Is there a real concern there? And I'm able to touch base with other of my colleagues in the NRC. I have a great resident inspector that goes out and does fabulous work. We're a team, and I don't think anyone in the NRC is a passive, oh, well, we're just gonna let them do anything they want. If they submit a plan extension, it's going to go through a very rigorous process from some extremely intelligent individuals, and it'll be highly reviewed. Reactor vessel, absolutely. I guarantee you that will be a subject of major concern for any licensed plant extension. So you're right on. We're not saying don't be concerned. The point is that I hope that you can understand that the NRC, Nuclear Regulatory Commission, takes its job very seriously. I take my job seriously. And if that plant is not safe for the public health and safety, we will not hesitate to take actions that we are allowed under authority of the U.S. government to take.
Could you order shutdown of the plant yourself?
Under extreme circumstances, the U.S. Nuclear Regulatory Commission could order a shutdown of the plant. I would not normally, if there was something of such extreme nature that I had to unilaterally do that, yes, perhaps that's under my authority. However, that kind of authority would normally be passed up to higher regard for that kind of operation.
He certainly has the ability to begin the process, and
Yes.
it would be an agency decision.
How
There are
long
a
would
lot
that
of
take
people
that,
who-
how long would it take you to decide to do that?
Depends on how
What it
urgent
is.
it is.
Depends on what it is.
If it's a 3 month, no.
If it was something very significant, I would imagine that the commissioners and the authority decision-making body of the NRC would be activated within an hour at least, if not faster.
Like an earthquake of 5.8 or higher hit,
Pardon me?
like an earthquake 5.8 or higher hit.
If an earthquake of 5.8 or higher hit, probably the plant would be shutting itself down anyways. And if that's beyond the design basis earthquake, then the plant, like the last
one?
well, like the last opportunity that did go high, the plant's not coming back up without extensive inspections and assurance that the plant is able to come back up.
I guess my question would be is after that, I wasn't able to find after the 2011 quake that we actually got full coverage of the inspection of the wells.
So I think with regard to the authorization for restart, there were a lot of inspections that were done.
Right.
And to a great extent, there there wasn't as much damage as you might have expected for an earthquake of that magnitude, that the plant actually withstood most of the damage very well.
Yeah, we're definitely
So,
lucky.
There are tremendously robust structural supports inside the plant.
But as they age,
Itself-
just like old cars and old people, I mean,
So-
you know.
Well, but again, to your point of second license renewal or, subsequent license renewal, I mean, that's going to be a very thorough evaluation. We have an entire division set up just to do license renewal evaluations. And so, just like the current operation, it wouldn't be authorized if we didn't have high confidence that the plant could operate safely.
Well, I hope so. I just hope as a Virginian that we don't end up dumping billions of dollars replacing a whole bunch of parts, only to find out that the vessel itself is cracked. Or I should take that back. We already know there's little small fissures because you guys say it in your own literature that there's small cracks. It's just, it says something like we expected not to have a 75% crack for 51 years.
But here's a key. You're right. There are cracks that are found, but the cracks can be repaired.
So are going to use that new peening or whatever it is, or is that for pipes?
I mean, they've been, weld repair and fracture repair is an established capability.
But in
established
the
science.
reactor vessel itself?
Yeah, there's code repairs that they would have to do, and that's,
Yeah.
and when we say code, that's in accordance with the American Standard of Mechanical Engineering.
I didn't think we've ever repaired a reactor vessel, have we?
We've repaired cold legs and hot legs.
Yeah, no,
We've
I'm talking about
repaired
the vessel
instrumentation.
itself. I don't think, I've
Well-
never read in the literature that we've ever repaired interior vessel.
We
The
repaired,
legs, yes.
We repaired reactor vessel heads.
The heads,
So
yes.
they've done some of those
But I'm
weld
talking
repairs.
about the body.
Yeah, because they're at, as far as, what we know, I don't think there's been a need.
I'm not aware of
I'm
any
not aware of that.
circumferential cracking of the beltline welds
No.
of that kind that you would be doing those welds that you're suggesting.
Right.
So you're saying that there's no cracks inside the vessel itself?
That's not what I said. I said I'm not aware of any
Just the belt
circumferential
line.
beltline cracks in that area that would cause you to be highly concerned with the vessel's integrity. So,
Okay.
Well, I'm trying to hit on other welds and other piping.
Oh, I know, we've got
Okay,
lots of it.
so the plan's
I mean, there's
full.
so much of it, it's a huge task in itself, I'm sure.
Huge, but
But
it's a
the
part
point-
of the process.
Yeah, but the point we're making is that those welds around the vessel, as well as the safe end nozzles to and from the vessel, those get high inspection frequencies and the highest of retention from both the licensee as well as the NRC.
Yeah, but only 88% or 80%.
So again, I reiterate for the third time.
I know,
88%
I
is
keep
pretty good
saying,
and inferring what the other 12%.
but
in addition to
evidently the
other
engineers that
12%.
originally
So-
designed it actually had expected 100% inspection at some point down the road. I mean, prior, and I don't know when it changed and when all of a sudden it became acceptable to do 80 or 80.
It didn't change, it's an individual case-by-case, weld-by-weld request. Yes. So,
Is there a question?
she just had some clarification.
Oh, okay. Well, I know my friend David had one question, and so I was just gonna ask too, because I know I probably asked it before. You know, talking about all these valves opening and closing and all this stuff. I mean, obviously, I forgot how many, is it 2 million gallons a minute or something rushes in from the river to cool the reactor. I mean, there's a lot of water comes in from the river to cool the reactor or to cool the fueling pools, I'm not sure, or both, right? We're using the water from the river.
Under normal
the lake.
plant operation,
Right.
they use river, what's called circulating water.
Right.
That essentially cools, comes in, is kept separate, causes condensation in the turbine,
Right,
and also provides cooling for things that are called component cooling, which are a separate cooling system.
Right.
That go into the containment and other, right into the aux building. And those are used to cool, with heat exchangers, other coolant systems that are related
Right.
to the radioactive, the primary coolant. So yes, you're right, you have the flow of around, at maximum about 2 million, gallons per minute through that, but it's not in the plant per se. I just want
right.
to make that
No, that I
clarification.
understand, but my
Okay.
question is when it's being pulled in,
Yeah.
I mean, it's a series of piping and valves and stuff too, right?
on that circulating water, there is not a whole lot of valves and.
So how does it,
it's-
how is it
it's
going,
just-
getting
it's-
reverted?
It's one big pump, and it's one straight pipe that goes into the condenser,
Okay.
and then out the condenser back into a very large pipe. I'm talking, a pipe that I can almost stand it, and then it's discharged to the hot discharge and the heat reduction facility.
So we never have to worry about something happening where something gets clogged or something happens where the water can't get in?
Well, there's traveling screens and things of that nature that
That
are
y'all
there to
clean.
keep, that they clean regularly, and the part of our inspection program is to make sure that they maintain those, and those keep, whatever potential could clog up that system. So, and you would notice it, even if you.
Well, I'm sure y'all would notice because of the flow difference, I'm sure.
Well, they monitor that flow rate coming in, they monitor the differential pressure across those screens
Yeah.
to see if there is any clogging that's going on.
Yeah.
If it reaches certain levels, then they have to, down power the unit, to be able to meet within that, or if they. But most of that water that's going through there, through the main condenser, is not unique to a nuclear plant.
Right.
They would do the same thing at a coal plant,
Right.
or,
Yeah.
it has to do with being able to run a turbine with steam going through it.
Right. Well, then I guess, my only question to that, in a hypothetical worst-case scenario, if an earthquake hit and the lake somehow got diverted or something,
Okay.
where would we come up with the 2 million gallons of
At
water?
North Anna, they have an additional cooling system called Service Water, and they have a 25 million gallon water pond that is
That's
dedicated.
25 million gallons?
Well, what that pond is you don't need all that water to
Right.
be able to support a non-100% power plant. So that water's coming through to be able to support making electricity, which is expanding the steam
Right.
that gets produced through the turbine and back
But I
into
mean,
the
if we
plant.
lost water from the lake, y'all could
plant-
use
the
the
plant would shut
25.
down.
They
the
have
service
a
water.
dedicated surface water pond
Okay,
that they
which is
use.
25 million gallons.
And they would use that to be able to cool the plant, and that basically, that service water pond has 30-day supply of water to be able to cool that.
Okay,
And
so,
that's for when the plant is shut down,
Right.
not operating.
well, yeah, I was gonna
So
say, because you couldn't
not
do that when it was
producing.
operating.
Right.
Yeah, so if you tried to do the math with 2
Right.
million gallons, that kind of,
Yeah, it wouldn't
it doesn't work out, but
Right.
that,
Right.
most of that flow, that 2 million is used for the condenser, which, if the plant's shut down, that's not online.
Right.
It's just to maintain the plant in a safe shutdown condition.
So
If
how
you
much
were
water
to-
is it using during safe shutdown procedures, like in an outage or something? Well, I guess no, there's always one reactor up typically, not all the time, but yeah. So I mean, is there a,
If both of them were shut down and they were using the water just to cool the reactor, I don't have that number off the top of my head. We could figure it.
all right, I was just curious, like I said, worst case scenario.
But the design of that pond is to have 30 days of supply to keep the reactor cooled while it's shut down.
Okay,
So
otherwise
it's
we,
the reactor and the spent fuel pool, which was the.
I was
other
gonna
part of
say,
the
because the
question.
spent fuel pool,
So,
that's
yeah.
constantly circulating, isn't it?
Both being cooled by the service water pond, which is the safety-related cooling source for the plant per design.
And, so we've got one for each reactor though, don't we? Or just one?
It is a combined.
Combined,
pool,
okay.
yes. So it is common for both units.
Okay, and so it holds how much water?
So I will have to get back to you.
Okay,
Substantial.
substantial, okay.
Takes me a while to walk around
When
it.
a new.
Yeah, I
when-
imagine.
When one unit is running, the thermal output is what, about 2,400 megawatt, if I remember correctly. When you shut down, your thermal load is probably on the order of 5 megawatt, maybe 5 to 10 megawatt, okay? So you're talking about at least 2 orders of magnitude less. So if it takes 2 million gallons, let's say 1 million gallon per unit, so reduce that by at least 2-3 orders of magnitude, and that'll tell you what the kind of flow rate you would have to have.
Oh, and I just wanted to touch on one last thing. So we have, with the experimental cask, is it number 27 of the TN32s?
Yeah, I believe it is number 27.
And then of the new homes, how many of those do we have?
Right now, they're just about filled up. I gotta check on that.
How many do we have?
I think there's 7 or 8 left.
Yeah, there's 7 or 8 left. And then
I didn't count them last month. when I was
Yeah.
there.
So I don't know how many we have of the new homes?
I'm not.
I can look it up if you want. Eric, I can get that to you.
So, I mean, obviously, under new license extension, that means these IFSCs are going to grow. because we're gonna keep creating this waste. Right.
Unless we begin reprocessing or the final deposit is created.
Well, that's nowhere in sight,
Well, I'm just saying, I mean, you know,
but, okay.
Those are the other options.
those are other options.
And so, well, I guess the best option would be to stop creating the waste in the first place, actually, but, you know, but at this point, because
The plants are
we,
operating right now, so we're gonna.
well,
do
they're
the
operating,
fuel
but aren't the spent fuel pool, isn't the spent fuel pool kind of full already, though? I mean,
And that's why there's dry cask storage,
right,
is to manage that. And
So-
so while the plant continues to operate within its license, it will continue to produce fuel that is spent.
so we're
It
leaving,
needs to be dealt with in some way. There are 3 ways: dry storage,
Right.
reprocessing, or the dedicated long-term storage.
or the temporary parking lot storage dumps that they're promoting in Texas and somewhere else, you know, somewhere temporary to hold it. So how long are we gonna keep this high burnup fuel in the pools? I mean, it's hotter, so are we keeping the higher burnup fuel in the pools longer than the other stuff? Or do we know? I mean, normally doesn't the rod sit in the pool for like, well, I think at one time it was 10 years or something, then it went to like 5 years or something?
The minimum's typically 5 years, but, you know,
Minimum.
it's all based on what's the thermal expectation. It's
So
temperature
the
dependent.
higher burnup, is it gonna stay in the pool longer?
Maybe, I couldn't tell you that on the top of my head. It's licensed by the Nuclear Materials Safety and Safeguards Group in headquarters, so they do the spent fuel part of it, we do the operating reactor part. So that question, we don't really have the expert here for you, but typically they move it out in not less than 5 years for any spent fuel.
So so we don't know how many new homes we have right now, but sounds like we had 8 spaces left, is that right? Did someone say 8?
Yeah, there's about 8 left.
About 8 left? So how often are we filling one of those new homes?
Typically, takes 1 to 2 casts every year.
1 or 2 casks a year?
Casts, so one or two of those spaces a year.
So we have 8 left. So we got 4 years left before we start having to build another.
And they've already started building the others, so,
Okay, so we're gonna go on pad 3 now?
yeah.
All right. Well, I guess I've asked plenty of questions. Thank you.
It just didn't sound.